Okay, here's an example problem that's a little more difficult than the first one. We're going to apply the same method that we've used before. Okay, in this case we have a soccer ball. It's kicked across the field. You can assume it's kicked horizontally across the field, so it's rolling across the field. It's not moving through the air. We're going to get to two dimensions later. It gets a little more complicated. So soccer ball is rolling across the field. After moving 15 meters, the velocity is 10 meters per second. How long did it take the ball to move that 15 meters? So let's go straight to our process, okay? Givens. Well, I'm told that it moves 15 meters, which is a distance, so my delta x is 15 meters. After 15 meters, the velocity is 10, so that's a final velocity, 10 meters per second. Sometimes we just say VF, sometimes we say V. If it's not V naught, V0, you can assume it's a final velocity. And that's all we know, nothing else. Okay, let's draw a picture. Okay, so here's my soccer ball, right, with a cheap checkered pattern. And it's traveling a distance of 15 meters, and its final velocity here is 10 meters per second. It's kicked. Let's make the assumption here, because I don't tell you the initial velocity, you can make the assumption that the initial velocity is 0. Typically, if it's not 0, we'll have to tell you that. So if it doesn't tell you, you can make that assumption. Okay, what am I solving for? What are my unknowns? Or in this case, single unknown. How long? Right? How long is time? All right. Equation. Okay, let's pull out our handy-dandy bag of equation tricks and see if we can figure this out in one step. Okay, so I need to find an equation with t, and I need to find an equation with v and delta x. So if I look at the first one, I got t, I have v naught. I'm going to write that down under my givens. V naught is 0 meters per second. So I know my initial and final velocity. I know the distance I traveled, but I don't know a, so I can't use the first one in one step. The second one, t, I don't have a again, so I can't use that because I have two unknowns, a and t, a and t. Third one, I know v, I know v naught, I know delta x, so this is the only one I can use, but it doesn't solve for t. So, but hopefully the light bulb's going off. Well, if I know a though, I can go back to the first one or the second one. The first being simpler, right? Because I don't have the t squared quadratic, I just have t. If I have a, I can go back to equation 1, use the a I find in equation 3, solve it in, and then solve for t. Plug it in and solve for t. So this is a two-step problem. So I'm going to start with equation 3. V squared is v naught squared plus 2a delta x. I'm going to use this to solve for a, and then I'm going to use the second one, v naught plus a t, plug in this a here, and solve for t. All right, two-step problem. Makes it a little more difficult. All right, so let's do my solving in blue. So I'm going to take this over here. All right, so v squared is v naught squared plus 2a delta x. I'm going to solve for a, so let's simplify using the variables. Right away, v naught is 0, so this term goes away, which is nice. I want to solve for a, so I'm going to have to divide both sides by 2 delta x. Cancels the 2, cancels the delta x, 2 delta x. And I got that a is v squared over 2 delta x. All right, substitute in. V is 10 meters per second squared over 2 times 15 meters. All right, so this is 30 meters. 10 squared is 100. So I have a is 100 over 30, or 3.33. And I have meters squared over seconds squared for my units, right? Over meters. So the meter squared cancels with the meter down here, and I'm left with meters per second squared, which is good. Always justify your units. So that's not my final answer. I'm going to use this now. If you're doing a longer problem, you might want to just send this up in the givens so that you know you have it. This will be important when we're doing projectile problems where you're looking at side-to-side motion and vertical motion separately, and there's certain terms that connect the two. So let's go to my last part. I know A now, so I'm going to solve V equals V naught plus AT for T. So let's subtract V naught over. So V minus V naught equals AT. And then let's divide by A. So my time is V minus V naught over A. So V naught is 0. V is 10. A is 3.33. Now if you're doing this in your calculator, don't since this isn't a final answer, I wouldn't cut it off. Use the full decimal. So my time then is, it should be 3, right? Double check. Yeah. 3.0 seconds. I'm doing a bad thing. Meters per second here. Meters per second squared here. Meters canceled. S cancels the square. And I have 1 over seconds, which means the second goes to the top. So just know what I did there. 1 over S. Right? If I simplify that, is the same as S. So I have 3 seconds. That's my final solution. And I have completed the problem. So remember, follow the steps. In this example, you can see a little more tricky, right? You got to do 2 different solves to get your final answer. So the more you organize your problem well, the more you set it up well, the better chance you have of reaching the positive result.